Welcome back. Today we have an exciting algebraic challenge. We are going to factorize the expression a cubed plus b cubed plus c cubed, where a, b, c are the lengths of the sides of a right triangle. Let's assume that the hypotenuse has a length of a, and the other two legs have lengths of b and c. According to the Pythagorean theorem, we have a squared equals b squared plus c squared. We can rewrite the original expression as a times a squared plus b cubed plus c cubed. Now, based on our first equation, we can substitute a squared with b squared plus c squared, and we expand the product. After expanding, we can group the terms and factor out b squared and c squared by grouping. But now what's next? Notice that from our Pythagorean equation, we can also write b squared equals a squared minus c squared, and c squared equals a squared minus b squared. By applying the difference of squares identity, we get b squared equals a minus c times a plus c, and c squared equals a minus b times a plus b. By substituting these into our previous expression, we get a new form, where we can finally factor out the common sums, alpha plus beta and alpha plus c. And that is our final factored form. If you enjoyed this algebraic twist, don't forget to like and subscribe. See you next time!